In this example, it is asked to find the velocity, acceleration, and speed of a particle with position vector, vector r of t, that is equal to the vector with x component t to the square, y component sine t minus t cosine t, and z component cosine t plus t sine t. For the velocity vector, the vector v of t will be equal to the tangent vector. So essentially, we need the derivative of the position vector. And that means that we'll need the vector of the derivatives of the components of the position vector. So this is equal to the derivative with respect to t of t to the square, which gives us 2t. The derivative with respect to t of sine t minus t cosine t gives us cosine t minus cosine t minus the negative t sine t. And the derivative with respect to t of cosine t plus t sine t gives us negative sine t plus sine t plus t cosine t. And if we simplify here, we get that the velocity vector is equal to the vector with components 2t, t sine t, and t cosine t. Now for the acceleration vector, we have that the vector a of t is equal to the derivative of the velocity vector. So that is equal to, again, the vector with components, the derivatives of the components of the velocity vector. So we have the derivative with respect to t of 2t gives us a 2. Derivative with respect to t of t sine t gives us sine t plus t cosine t. And the derivative with respect to t of t cosine t gives us a cosine t minus t sine t. Now for the speed, we know that the speed is equal to the magnitude of the velocity vector. So essentially we need the square root of the sum of the squares of the components of the velocity vector. So we have the square root of 2t to the square plus t sine t to the square plus t cosine t to the square. So that is equal to the square root of 4t to the square. And then from the second and third term, we have a common factor of t to the square. And then we have inside a parenthesis sine squared t plus cosine squared t, which is equal to 1. So that gives us the square root of 4t to the square plus t to the square. And that is equal to 5t to the square underneath the square root. So, and since we don't know what values t takes, so it might take either positive or negative value, this is equal to the square root of 5 times the absolute value of t. Therefore, the speed is equal to square root of 5 times the absolute value of t.